Solving a cubic. Okay, so if we want to solve a cubic, and so they have x equals 3, 2x plus 2x squared minus 1 is greater than or equal to 0. And it asks us to solve graphically. That's what the textbook asks. By the way, I've noticed that when you guys do the homework, so in some of our homework problems, it'll say solve graphically, solve algebraically. And what I've noticed when I look at the homework is some of you guys like doing it algebraically, so you do it algebraically for every problem, right? Even though it tells you to do it graphically. Or some of you guys like to solve it graphically, and you do it graphically for every problem. There is a great value though in being able to do both. So when your homework says solve graphically, solve it graphically. When it says solve it algebraically, solve it algebraically. And what you'll find is when you take an important test like the ACT, being able to do both. In other words, if I solve a quadratic equation algebraically, then I solve it by looking at the graph and using my calculator. If the two answers match up, I could be pretty confident in my answer. Okay? Because there's no answers in the back of the book on the ECT, right? So we got to learn how to get the answers ourselves. So what I want to do is, since it says to solve graphically, I'm going to come in here, plug that bad boy into my graphing calculator, like so. So I'm going to say x raised to the third power plus 2x squared minus 1. So I'm going to graph it. And what we're going to look for is we're going to think to ourselves x cubed plus 2x squared minus 1 is equal to 0. That's what we're going to think. Right? And then we'll address this. So we're going to think that. We're going to think this and address this inequality symbol after we've found our solutions. So I'm going to sketch the graph. This is my y-axis, my x-axis, and I'm going to zoom in a little bit because I really want to see. I don't know if it crosses here or if it just touches there. So I'm going to zoom in a little bit in the y direction. So I'm going to make my negative y window to be like -2 and my positive y values to be 2. And I think we could probably zoom in a little bit in the x direction. So I'm going to say -5 to 5. Okay, so what I have here is I have a graph that kind of swoops through here, comes down like this, and comes out. So I'm looking for these three intercepts. And we'll solve that graphically in a second. Okay? Now, how do I solve that graphically? The same way I would with the quadratic equations. I'm going to go to my calculate menu and solve for the zero. So I'm going to start with my first one all the way over here, find the left bound, go a little bit to the right and find the right bound. See how it tells, my calculator tells me what to do right here. See that? Then it says guess, and I'm going to go in the middle. Alright, so my first x-intercept occurs at about -1.62. Now let's do the next one. I'm going to hit second trace, which pulls up the calculation menu or the calculate menu. I'm going to move around here a little bit to the left, a little bit to the right. I'm going to try to guess. The next x-intercept occurs when x equals -1. Okay, and so now I'm going to keep moving around. So I'm going to hit second calculate, 0, come around to the next intercept. Oops, we got to be a little bit to the left, a little bit to the right, and then try to guess. Well, I guess that's the best I could do. And so my next x-intercept occurs when x is 0.61, or well, let's just make it 62, right? And we'll change this to my approximation symbol. And so now just a kind of a quick refresher, what this means is this point is negative 1.62 comma 0. This point here is negative 1 comma 0. This point here is 0.62 comma 0. And notice that all three y values are equal to 0. Okay? So now what we're trying to do is we're trying to find out when this stuff is greater than or equal to 0. So we're looking for stuff above the x-axis. So when we follow the curve, we're looking for that and for that. Now, but we're looking for it on the x-axis. So we're really looking at the x-axis here and here. Now this one's going to be a little trickier to kind of write out. In other words, if I draw only the x-axis over here on the side, I have 3 points. I have the point negative 1.62. I have the point negative 1, and then I have the point 0.62. Now what I'm really interested in are this boundary here and this boundary. Okay? Now how do I write that though? Right? Like how do I, these are inclusive because I have the underline, because I have the equal sign. So I'm gonna bind these. All right, those are inclusive. We're including these values, and I'm including that value. So now how do I write that? Well, I could say negative 1.62 comma negative 1 union 0.62 comma infinity. And that's pretty much it, isn't it? Does anybody have any questions?